What's up, Math Padawans? Here we go. Let's do some examples with multiplying decimals. So I got 5 of them up here that we're going to roll through real quick. Remember, if you need any help, make sure that you reach out and you ask me. If you need to slow it down, rewind it, do that, right? You can do that. So take advantage of this technology that you have, and let's get it going. All right, first question says to estimate 6.7 times 2.2. When we estimate, we're going to round these numbers to their nearest whole. So 6.7, we'd underline our 6. We'd circle our 7. The 7, is it 5 or more or 4 or less? If it's 5 or more, we're going to raise this up to a 7. If it's 4 or less, we're going to let it rest down to a 6. So since that 7 is 5 or more, we're going to raise it up. This turns into 7. So this number is 7. The second one, 2.2 or 2 and 2 tenths. If it's 5 or more, we're going to raise it up to 3. If that circle number is 4 or less, we're going to let it rest at a 2. So since it's 4 or less, we're going to let it rest. It stays at 2. So this problem really, as an estimation problem, turns into 7 times 2, which is about 14. The answer to this problem is going to be around 14 holes. All right, second question we're going to look at. It says, Molly knows that 45 times 811, by the way, we're up here. She knows that 45 times 811 is 36,495. Use this understanding to help Molly solve 4 and 5 tenths times 8 and 1 tenth. So that's up here. So we don't even need to multiply this out. All we need to do is we need to look at our two numbers and see how many total digits are behind the decimal point. So if I look at my first number, this 5 is behind the decimal point. If I look at my second number, this 1 is behind my decimal point. Now that I've looked at those, how many total digits, total altogether, how many total digits are behind the decimal point? Hopefully you said 2. There are 2 digits, 1, 2 behind the decimal point. So that means our answer is going to have 2 digits behind the decimal point. This option A has no decimal point. So really the decimal point would go at the end. There's nothing behind it. That's not our answer. B has 1 number behind the decimal point. We want 2 total digits behind the decimal point. So B is not correct. C, we have 1, 2, so that is correct. C is going to be our answer. D has 3. We only need 2, so D is not correct. So that's correct. Also, I could just say 4.5 would be about 5. 81 would be about, 81.1 would be about 80. So I'm doing some estimation here. 5 times 8 is 40. Add that last 0, that's 400. Which of these answers over here is closest to 400? My estimated answer. The only one that's even close to it would be this one right here. All right, so now let's just do some straight up math. All right, so we're going to do these 3 problems. We're going to do them kind of quick. 0.7 times 0.3, 0.7, 0.3. I'm going to times them together. 7 times 3 is 21, carry the 2. 3 times 0 is 0, plus 2 is 2. I almost said 5. Common mistake. I don't even need to multiply times this other 0 over here, so I'm just going to get 2, 1. Now, how many total digits are behind the decimal points? I have 1 here. I have 1 here. So altogether, there's 2 digits behind the decimal point. So that's 1 digit, 2 digit. That means my decimal point has to go here. My answer to this question is going to be 0.21, or I always like to, if it starts with a decimal, write 0.21, or mathematically we'd say 0 and 21 hundredths. All right, next question. Here we go. Let's use purple because why not? 5 tenths times 6 and 8 tenths. So I'm going to put the 6 and 8 tenths on top because it has 2 actual digits, and the 0.5 has only 1 real digit. The 0 we can actually not really work with. So we're going to times these together. 5 times 8 is 40. Carry my 4. 5 times 6 is 30, plus 4 is 34. I don't need to multiply. So, I'm done with the 5. I'm done with the carry, but I don't need to multiply because I'm just going to get 0, 0, 0, 0, all these zeros. So this is going to end up being 3, 4, 0. Now, again, that's if it was 68 times 5. 68 times 5 is 340, but we use a decimal point. How many total digits are behind the decimal point? We have 1 here. We have 1 here. So altogether, that's 2, right? Now, even though this is a 0 back here, we still need to count it as 1. So it's 1, 2. So my decimal point has to go here. So I get 3.40 or 3 and 40 hundredths, or we can just simplify it and just get rid of that 0 and say 3 and 4 tenths. Both of those would be correct. So I'm going to try to write this up here. It's hard to kind of write. But I'd get 0. Nope. No, I wouldn't. I wouldn't get 0. I'd get 3 and 40 hundredths or 3 and 4 tenths. I like 3 and 4 tenths better because we don't really need the 0. All right, last example. Here we go. What have I used? Blue, green, purple. Let's use red. I already used red. Whatever. Who cares? I'm taking too much time. Let's do this color here. Great. All right. So our last one is 31 and 4 tenths times 5 and 68 hundredths. Real quick, I'm just going to do a quick estimation. This is about, if I rounded the tens place, this would be about 30. This would be about 6. So 30 times 6, 3 times 6 is 18. Carry the 0, and we get about 180. The answer to this is going to be around 180. It's not going to be exactly, but that's just a quick estimation. All right, so let's actually do the math. 31 and 4 tenths times 5 and 68 hundredths. Now remember, we do not need to line up our decimals, so don't worry about that. The only time they line up is when we're adding and subtracting. All right, so here we go. My sloppy 8, that is an 8. Yeah, 8 times 4 is 32. Carry the 3. 8 times 1 is 8 plus 3 is 11. Carry the 1. 8 times 3 is 24 plus 1 is 25. So I've done everything with this sloppy 8. I'm going to cross off my carries so I don't use them again. Now I'm going to go to my second line. Start with the 0. Do 6 times 4 is 24. Carry my 2. It's kind of hard to see that. Oh well. 6 times 1 is 6 plus 2 is 8. 6 times 3 is 18. Doing my best to line them up. Done with my 6. Done with that 2. Now we go to my third line. Third line, we're going to have to start it with 2 zeros. 1, 2. Now I do 5 times 4. 5 times 4 is 20. Carry a 2. 5 times 1 is 5 plus 2 is 7. 5 times 3 is 15. Ooh, it's getting ugly. That's all right. I'm going to add them up. So I get 2, 5, 13, 10, 11, 18, 7, 1. 178352. If I multiplied 314 times 568, I would get 178,352. But now we go to our problem, and I'm going to use a different color, and I'm going to use yellow. When we're doing this, how many digits are behind the decimal? I have 1 here. That's kind of hard to see. And I have 2 here and 3 here. I have 3 digits behind the decimal point. That means 1, 2, 3 digits need to be behind the actual decimal point. So when I put my decimal point, I'm going to put it right there. We also talked earlier and said the answer is going to be somewhere around 180. Well, the only decimal point location, if we put it in any of these spots, the only one that would make sense to be close to 180 is where we have it, 178 and 352 thousandths. All right, guys, if you have any questions, make sure you reach out, ask. You can rewatch it. If you have any questions, comments, concerns, you know who to talk to. All right, stay safe, stay healthy. Peace.